The first problem is to rotate an array. We need rotate an array means if we have an array, that is, let's say I have an array and the element of an array is 5, 7, 10 and 6. I have to rotate it. That means after performing my algorithm, the array should be like this. The last element will come the first position, then 10, then 7, then 5. So what we need to do is we will just swap the last element with the first element. That means 6 and 5 just swap their places, and 10 and 7 I will swap them also. So 10 comes to the second position and 7 goes to the third position. So here the number of element is 4, that is here the number of element is even. That means I need two pointer. One is, let's say one is I and another is J. So I will swap the element at a position I and position J, and after this I will increment I and I will decrement J. I will do the same thing until I and J both crossed or they both meet. Here after swapping of 5 and 6, I incremented I to this position and I decremented to J to point this position. Then after my swap is done, then my I will come to here, I will increment and come to here, and J will decrement and come to here. So we can clearly see that I and J both crossed each other, and if they crossed each other, that means my entire array has been rotated, and I need not go for any further iteration. Let's say if my number of element is even, let's say for an example number of element is 3, if my number of element is odd. So if I have 10, 20 and 30, this is index 0, 1 and 2. My I is initially at 0 index, my J is initially at second index. So I will swap 30 and 10. After this I will come increment and come here, and J will decrement and come to here, come to 1th index. Here I can say that I and J both has met. That means here I don't one thing is that I can swap 20 with 20, or I can I don't perform any swap. So both are absolutely okay. That means I will write my condition of loop like I less than J. So when this condition is satisfied, then I will increment I and I will decrement J, and and before that I will swap the element of index I and J.
Now let's come to the implementation part. What we have discussed earlier, we will implement it here. So we will recommend you to pause the video, try to implement the code by yourself, and then come back to the video again to clarify that your implementation is correct or not. Okay, so let's start with the implementation. First we have to make an array. I'm making an array named ARR and with the size of max, which is defined here. Okay, and I am taking another variable n, which will store the size of the array. Okay, at first let's take the size of the array. Okay, and also inform the user by a message that enter the size of the array. Okay, now let's print a message like enter the elements of the array. Okay, and run a loop from 0 to less than n and take elements of the array one by one. Okay, we are done with all inputs, right? Now the real parts come. Okay, so what we have to do here, we have to reverse the array, right? So let's make a function, name it reverse, which will take the pointer of the array and size of the array. Okay, let's come here and write the reverse function. The return type should be void because it is not returning anything to us. Okay, it is just manipulating the array. Okay, now let's continue with the function. The parameters will be array itself and the size of the array. Okay, pointer to the array and size of the array. Now, as we have already discussed the algorithm, we will make two variables I and j. Okay, I and j. Okay, so I will point to the first index of the array, so I is initialized to 0, and j will point to the last index of the array, which is n minus 1. Okay, now let's run a loop while I less than j. What we will do, we will swap the ith index with the jth index. Okay, and increment I and decrement j. Okay, so far so good. And the swap function is not pre-built, so we have to make it by ourselves. So let's make the swap function like this. This will also return nothing, so void will be its return type. Okay, and as we are going to directly modify the value of the arguments, so let's take it by reference. Okay, let's take it by reference, and okay, like this. Okay, we are taking it by reference because we are going to change the value of the arguments, right? Okay, now let's write a simple swapping algorithm. Okay, and I'll put the x y into x and y will be assigned as temp. Okay, great. So we are done with reversing the array. Now we have to print the array, right? So I am making a function print which is also taking the pointer of the array and the size of the array. Okay, let's write the print function. The print function should return nothing, so it's void, and it is taking the pointer of the array and size of the array. Okay, now let's just print all the elements of the array. So I'm running a loop from I0 to n. Output the array and making a giving a space so that it looks better. It looks for. Let's just put a new line here at the end, and we are done with our implementation. Now let's try to compile the code. Wow, error because I have not written ARR here. Okay, I think that's cool. We are done with compilation. Now let's run the code. Okay, I'm giving 5 elements. Okay, 1 2 3 4 5, and see, it has reversed the array. Okay, let's try to compile it again with a even number of input. Okay, we are giving 6 elements this time, and 1 2 3 4 5 6, and it also reversed this. Okay, then we are done with the implementation and it's working completely fine. Okay, thank you for watching the video and have a good day.